So, beginning of chapter 4, they talked about graphing quadratic functions. And we know that quadratic functions are functions that have an x squared in it, right? And we've talked about standard form before.
Algebra, please call the front office.
Standard form for a quadratic equation is what? Since we had a quiz on this last week. A x squared plus bx plus c equals 0. So for today's lessons, all of our equations will be in this form, called standard form. And we are going to graph parabolas. A parabola is what we call the graph of a quadratic function. So a parabola is what we call the graph. Say parabola.
Parabola.
Parabola, not parabola. It's not parabola. It's parabola. Okay? The emphasis is on the rab part, like rabbit.
Rabbi.
Like rabbi. Parabola. All right. So here's what a parabola looks like. Let's talk about the parent function for a second. It is y equals x squared. That's the most basic parabola there is. And let's say we wanted to graph that. We'd make a table. We'd pick some x's. I plug them in to x squared. What's negative 2 squared? 4. What's negative 1 squared? What's 0 squared? What's 1 squared? What's 2 squared? And what do you notice about these y values? They start repeating, don't they? And these are all positive, but they're not always going to be. But these start repeating each other, right? That's because parabolas are symmetric. What they look like on one side, they're going to look like exactly the same thing on the other side. So when I graph this parabola, graph these points, it looks like this. We need to make sure that when we connect the parabola, it makes a U shape, not a V. And mine is terrible. Because a V shape is an absolute value function. Parabolas are more like a U. A V shape is absolute value. So what happens is this one goes from left to right, it goes down and then it comes back up. This is the parent function, so it's the most basic parabola that there is, y equals x squared. Okay? And we did this one by making a table. Which if we have simple quadratic equations, that's how you would want to do it. Okay? We'll talk some more about properties of parabolas in a second. We're just going to gradually add to our repertoire, our knowledge. So example A here, we're going to graph by making a table. And then we'll learn another method of graphing them in just a second. Y equals 2x squared. So the first one we graphed was y equals x squared. This one is y equals 2x squared. So we're going to make a table. Pick your x's, and if I were you, I would pick negative 2, negative 1, 0, 1, and 2. Because if I start putting in big numbers, say I plug 10 in for x, well 10 squared is 100, and 2 times 100 is 200. I'm not graphing a 200. I'm sorry. It won't fit on my screen, for one thing. All right, so we want to pick numbers that are close to 0 if we're going to be graphing them by making a table. All right, so let's plug these in. Now, when we plug them in, mind your order of operations. So in order of operations, what do you do first? Do you multiply or do exponents? Exponents before you multiply. So we're going to square first. So what is negative 2 squared? positive 4. And what is 2 times 4 equal? 8. And to save us lots of time and energy, if this one right here is 8, it's going to match up with this one down here. Yeah, because parabolas are symmetric. So after the vertex, they start repeating. So we can check it. If we want to plug in the positive 2 instead, 2 squared is 4. 2 times 4 is 8. Right?
So the next number 2.
Yeah, 2 times 1 squared or negative 1 squared is 1, and 2 times 1 is 2. So this one's 2, and this one's 2,
The next one is 0.
and the next one is 0 because so you don't even have to work out all 5 numbers. You just basically have to work out 3, and then they repeat. Does that make sense?
Yeah.
This one matches up to this one, and this one matches up to this one. So it don't matter if you plug in the negative or the positive, they start repeating. So then you just graph your 5 points on an axis. This one has to go all the way up to 8, so make sure you accommodate your size of your graph with your y values. So left 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. Left 1 up 2. 0, 0. And then they repeat. It's always easy to graph the second point because, like, however, this is the center line. It's called the axis of symmetry. We'll talk more about in a second. But however far you are away from the center, you go the same distance in the other direction. So, like,
It looks a whole lot like a V.
It does. And I'll tell you why. We got to be careful graphing these to make them U-shaped, though. The reason this one looks more like a V is because it's going to be more steep because there's a number in front of our x squared that is bigger than 1. So anytime we have a number that is bigger than 1 in front of our x squared term, it's going to make the graph more narrow. It's going to stretch it up. So that's why it looks more like a V. So if we have a fraction in front of our x squared, what do you think that's going to do?
Smaller, wider.
It's going to make it fatter. Fractions make you fat. Which makes sense, because if you ate whole pizzas, it should make you fatter than eating fractions of pizzas. But fractions make them fat. That's how I remember it, double F. Also, notice that this is a positive in front of the x squared. Also, in the original one is a positive 1 in front of the x squared. That makes you have a U-shaped graph. So what do you think happens when you have a negative in front of the x squared?
It's wider.
No, the negative don't make it wide or narrow. The negative in front of the x squared turns it upside down. Yeah. See, like this one's like a valley. So if I have a negative 2x squared, it's going to be upside down. It's going to be a hill. Yeah. Yeah. Okay, so let's talk about some properties of parabolas. And your book actually has a nice list of these on page 237. I like their list. One thing, if A is positive, y'all know what I'm talking about with A, right? AX squared plus BX plus C. So if the number in front of the x squared is positive, the U will open up, like we were just talking about. It'll be a U shape. And if A is negative, it'll be upside down. So you have a regular U-shaped parabola if A is positive. You have an upside down U-shaped parabola if A is negative. Another property. If A is greater than 1, we just said, it'll be narrow. And if A is less than 1, if it's a fraction, the parabola will be wider, narrow. Also, we have something called an axis of symmetry. We talked about parabolas being symmetric. And that is the line x equals negative b over 2a. We learned back in Algebra 1 that x equals a number is a vertical line. So our axis of symmetry will be the vertical line that goes through the center of our parabola that makes everything else symmetric. So if I were to fold my parabola along my axis of symmetry, everything on both sides should match up with each other. So what we're going to do from now on is talk about graphing from the original standard form. So example B, y equals 2x squared minus 8x plus 6. Now I'm going to go ahead and tell you now, this is kind of a long process. It's kind of a long process. Okay? So we're not going to make a table on this one like we did the other two. The other two were simpler equations. Tables work great for those. But when you have a whole standard form of a quadratic, the table method is really not the best way to do it. For one thing, the vertex is not at 0, 0. Okay? On both of those, the middle of the parabola was at 0, 0. That's not the case with the rest of them. Okay? So we need to first find the vertex. And before we find a vertex, we need to start by finding the axis of symmetry. So the first thing we're going to do is find our axis of symmetry. You need to memorize the formula for an axis of symmetry is x equals negative b over 2a. X equals negative b over 2a. So remember our quadratic equation in standard form. This is our a, this is our b, this is our c. Right? So we're going to plug in. Negative parentheses. What's our b? Negative 8 over 2 times what's a? 2. And then we simplify. A negative 8 is a positive 8. 2 divided by 2, or 2 times 2 is 4. And 8 divided by 4 equals what? 2. So our axis of symmetry is the line x equals 2. And write x equals 2 because it's a vertical line. So don't just say it's 2. Say x equals 2 because it's a vertical line. All right, so we got a vertical line. That's our axis of symmetry for this graph. So we need to find the vertex. Now the vertex is the very center point. We've got the line that the vertex is on. We need the very center point for that line. So what we have right here is the x value it's going to be. So we need a y value to get a point. So how do you think we could get a y value? This is y equals 2x squared minus 8x plus 6. Right? And we know that x equals what? So how can we get y? Plug 2 in for all the x's. Okay, so that's what I'm going to do. Y equals 2 times 2 squared minus 8 times 2 plus 6. So everywhere there's an x, I'm plugging a 2. And where did I get my 2 from? My axis of symmetry. Yeah. So order of operations, we square before we multiply, right? The square is an exponent. So what is 2 squared? 4. And then we can multiply. 2 times 4 is what? 8. Negative 8 times 2 is negative 16 plus 6. And I can add, subtract, left to right. That's negative 8 plus 6, which is what? So the point 2 comma, -2, this is my y, this is my x, is my vertex. Okay? Now, after you get your axis of symmetry and your vertex, you're ready to start graphing your parabola. So, draw yourself an x and y axis. And then your vertical line should be a dotted line because it's not really part of the parabola. It's just a kind of like a marker. So that's why we make it dotted. And I'm labeling it AOS for axis of symmetry. And then the point for our vertex better be on that dotted line. So I went to -2 because that's my axis of symmetry, x equals 2. I went to +2. Graph the vertical line, and 2, -2 is on that line. So graph the point 2, -2. There it is. There's your vertex. That is one point on your parabola. It's actually the very center point on your parabola. So after you graph your vertex, you want to pick another x. Now guys, our x right now is at 2, right? Our axis of symmetry is at 2. We don't want to pick something far away from our axis of symmetry. Like I probably don't want to pick 10. For one thing, it's off my screen. I probably don't even want to pick 5. Because when I start squaring numbers, it jumps up really fast because 5 squared is 25 and 2 times that's 50, and that's big numbers. For graphing, it is. So, pick a number that's kind of close to your axis of symmetry. 0 is only 2 spaces away, isn't it? And 0 is an easy number to do math with, isn't it? So I'm going to do that. Let x equal 0. So pick an x close to your axis of symmetry. I would go 1 or 2 spaces over. So now I'm going to take that original equation, and this time everywhere there's an x, I'm going to plug in a 0. So y equals 2 times 0 squared minus 8 times 0 plus 6. Well, this makes 0. This makes 0. And 0 minus 0 plus 6 equals what? 6. So 0, 6 is a point on my parabola. So it's on the y-axis, isn't it? 1, 2, 3, 4, 5, 6, way up there. I almost didn't have room for it, but there it is. This last point is the easiest one. How many spaces away is this point from my axis of symmetry? 2. So to match it up, I go how many in the other direction? Yeah, I can go 2 in the other way, put a point there, and then you make a U out of it, and then you're done. So all I require when you're doing these is 3 points. The vertex, pick one x, and then
What's
go.
that little V down at the bottom?
That's my arrow for my line.
That's the one I like.
This is the vertex. I labeled my vertex with a V for vertex.
So when do we use these?
That's your vertex. That's this point. Plugged in my axis of symmetry and got my vertex.
So we're always going to be doing these.
That's called a parabola, yes.
Okay.
A graph of every quadratic is a parabola. Yes. Seriously, this is the longest one we're going to do because it takes me forever to explain it the first time. Okay? And we're just going to practice the same thing for another day and a half, and we're going to be really good at this.
No homework.
I didn't say that.
I heard that.
No. I'm also going to tell you tonight. You know how many of these you got to do? 6. That's it.
Yeah, that's it. 5.
6.
I'm not 5. Stay here is going to be.
6. All right, let's do another one. Y equals -x squared plus 6x minus 8.
Okay, the other thing is 2. And what's the other formula?
X equals -b over 2a.
Oh, yeah.
Yeah, that's what I'm doing first. All right, so before I even start this, y'all, what does that mean that a negative is in front of the x squared?
It's going to be upside down. It's going to be a hill.
Yep, it's going to be an upside down parabola. Very good. So that's something to always make yourself a mental note. Before you even graph it, before you do AOS, before you do anything, look and see if it's going to be a U or an upside down U. And that negative means it's going to be upside down. Okay? So if we graph it and it's not upside down, we're wrong. All right? So first thing you got to do is find your axis of symmetry. That's what AOS stands for, axis of symmetry. And that is the x equals negative b over 2a. So negative parentheses 6 over 2 times what's a? Negative 1, right? Are y'all okay with how I plugged in my b and my a? Simplify. Negative 6 is negative 6. 2 times negative 1 is negative 2. And what is negative 6 divided by negative 2? Or, no, it's positive 3. Yeah. So x equals 3 is my AOS. That's my vertical line. Now I need a vertex, which is an ordered pair. You plug in 3 for my x's. Very good. Plug in 3 for my x's. So now y'all be careful plugging in here. That negative x right there is negative 1x. So I would say negative 1 times 3 squared plus 6 times 3 minus 8. Remember, order of operations, do your exponent first. So what is 3 squared? 9. And what is negative 1 times 9? Negative 9. So if you don't do those order of operations there, you're going to miss that part with a negative. 6 times 3 is what? 18. And minus 8. Negative 9 plus 18 is 9 minus 8 equals 1. So put the x and the y together. What do you get for your vertex? 3, 1. There you go. Now you're ready to start graphing. So draw your graph. We said this one's going to be upside down. So you go to 3 on the x-axis, make a dotted line. That's your AOS. And 3, 1 is right there. There's your vertex. That means your other points better be lower than that one. It's always vertical. And your vertex always has to be on the AOS. Y'all with me? Lee, you with me? She fly. All right. So then you pick an x. Now, I would pick 0, but if I can do some quick math in my head, if I plug in 0 for the x, I'm going to be all the way down at negative 8, and I just didn't really draw my graph down that low. So I'm going to pick 1. Let x equal 1. Plus 0 is 3 spaces over. I want to stay within 2. Just makes life easier. So y equals negative 1 times 1 squared plus 6 times 1 minus 8. So everywhere there's an x, put the 1 in. Then I do my arithmetic. 1 squared is 1. Negative 1 times 1 is negative 1. 6 times 1 is 6. And then minus 8. Negative 1 plus 6 is 5. And 5 minus 8 is what? I just said it what it was in my head. What's 5 minus 8? So what ordered pair is this point? 1, negative 3. That is on my parabola. So go to 1 and go down to negative 3. And then how many spaces is that from my dotted line? 2. And then I go how many in the other direction? 2. And you make yourself an upside down U. Put arrows on it. And there's your parabola.
So technically, you're trying to find 3 of them.
You're finding 3 points. So your AOS helps you get your first point. Then you pick an X value 1 or 2 places away from that AOS, that dotted line. Plug that in, get your second, and then you count the spaces over to get your third. That's it, every single time. Every single time. Let's do one with a fraction. This one they say f of x. How do we treat it when they say f of x? Pretend that f of x equals y. It's the same thing. So y'all help me out. What do we do first?
A, B, C.
A, B, C. There we go. Now what?
And then it's going to be a...
What do we have to find first?
Valley.
Yep, it's going to be a regular U shape. Wide or skinny or normal?
Wide.
What makes it wide?
Fraction.
The fraction from the x squared. Very good. So yeah, we know a lot about a parabola without even seeing the graph. Okay, if we just look at that a term, that tells us a whole lot. So first we have to find the what before we can graph anything. Axis of symmetry. Always start with your axis of symmetry. So x equals negative b over 2a. So negative, what's b? Yeah, there's a 1 in front of that x. Over 2 times, what's a? A half. So that's negative 1 over 1, right? And that's negative 1. So x equals negative 1 is our axis of symmetry. How do we get the rest of the vertex?
Plug it in as x.
Plug negative 1 for all my x's. So 1/2 times negative 1 squared plus negative 1 minus 2. Order of operations. We do the square first. What's negative 1 squared?
1.
1. What's a half times 1?
50
Half. Yeah, half $1.50. Good job. So a half minus 1 minus 3. That's a half minus 4. Right? So what's that do? 3.5? Yeah. Right? How am I going to graph that? I don't know. How do you think I'm going to graph that?
Make the point by half.
Yeah, go about halfway. That's how I graph that. Yeah. So, yeah, that's how you graph a half. You go about halfway. It ain't rocket science.
You not just draw your thing and do every other one. Do each one of it by half.
Yeah, that gets really crazy. All right, for one thing, our axis of symmetry is at negative 1. So we go to negative 1. Oh, I didn't go down low enough, did I? I got to go down to like 3.5. So there's my AOS. And negative 3.5, I go down 3 and go down about a half more. So halfway between negative 3 and negative 4 is negative 3.5 down there. Y'all with me? Don't let the fractions throw you off. All right, now what do? That's one point. How do I get my second point?
3.5 in fraction.
No, you don't. So you pick an x. Pick a x, don't you? Yeah, you pick an x. You could pick 0 or you could pick 1 because those are both about 2 spaces away, 1 to 2 spaces away, right? 0 is really easy, but they really don't tell us much about this graph. It'd be at negative 3. So let's do that. Let's pick 1. Let x equal 1. So a half times 1 squared minus 3. What's 1 squared? A half times 1 is a half, right? A half plus 1 minus 3 is the same thing as a half minus 2, which is what, negative 1.5? Right? A half minus 2 is negative 1.5. So 1 comma negative 1.5 is a point on my graph. So I go left one, or right 1 down 1.5 right there. Negative 1.5. And I'm how many spaces from my dotted line? 2. So I go 2 more again and put a dot in the same spot. And then we make a U. And as we can tell, it's supposed to be wider. My U looks like a V. The arrows on it. And you're done. So yeah, the fractions for the A term should make them wider. Positives make it look like a U. Negatives make it upside down. Numbers bigger than 1 for the A term make them skinnier. All that good stuff. All right, any questions?
That's as complicated as it gets today.
This is complicated, yes. We do have one more thing to talk about. The vertex a little bit more. So, any questions about graphing them though? Okay, you're going to do the same thing every time. Find the AOS, plug it in, get your vertex, graph those two. Pick an X value, plug it in, get the Y value, graph that point, go the same number of spaces across the AOS, graph the third point, make a U. Okay? All right, so the last thing we're going to talk about is maximums and minimums. Now, maximums and minimums are referring to your vertex. Okay, they come from your vertex. So remember, if we have a U-shaped graph, the vertex is down there, right? So that's the lowest point. Therefore, that is called a minimum. So if we have a regular U shape, that's when the A term is positive, we're going to have a minimum. And if the A term is negative, that means our parabola is upside down. That means the vertex is up here, which is the highest point. So that is called a maximum. So if your vertex is the lowest point, it's called a minimum. If it's your highest point, that's called a maximum. So this one happens when A is negative. And a minimum happens when A is positive. Now sometimes, like right now, it's going to ask you to find the vertex and tell whether the vertex is a maximum or a minimum without having to graph it. Can we do that? Yeah, how? You just know it's possible, right? You just know it's possible. Okay. Here's the directions.
Without graphing?
Tell whether the function.
For negative, like you said, it's with the first sign.
Very good. I knew y'all could do it if you thought about it. Maximum. If I put max, y'all know that's maximum, right? And if I put min, y'all know that's minimum, right? Then find. Okay. So I think this is example. What was that last graph? C. This will be example D. They give us y equals 3x squared minus 18x. So if it says find the maximum or the minimum, it's talking about the vertex. Okay? Because you know the vertex is always going to be the point in the middle. It's either the highest point or it's the lowest point. Okay? So y'all tell me about this parabola. I'm not doing anything else yet. Y'all tell me about this parabola. Is it going to be a U shape or an upside down U shape? It's a regular U shape, right? So the vertex will be like down here. So the vertex will be a what? Minimum. Did I even have to work it out to answer that part of the question? Minimum. So that's why I like doing a little sketch. Like that's my little graph. There's my little vertex. It's a minimum. So we got to find the minimum. And the way we find the minimum is to find the vertex. Well, how do we find a vertex?
AOS.
You got to find the AOS first. Yes.
Would it not be simplest to write minimum at the end of the whole fellow?
You could. You could. But it really doesn't. You're still going to have to look right here to tell it. You're not graphing these? So if you were graphing it, it'd be easy.
Oh, okay.
But we're not graphing these. All we're doing is telling me if it's a max or a min, find the AOS and then the vertex. So x equals negative b over 2a. So negative plus b is 18 over 2 times what's a? 3. Negative 18 is 18. 2 times 3 is what? 18 divided by 6 is 3 whole. It's just 3. Yeah, don't overdo it. There you go. So there's that. Now that's not my whole vertex. That's just the x value. When I'm looking for the maximum or in this case, the minimum value, I want the y value, which I plug it in to get the vertex. That's all I have to do. So y equals 3 times
3 squared.
Okay, then you mind your arithmetic and do your square first.
3 squared is 9 times 3 is
27. What's negative 18 times 3? Negative 4. Good. Plus 20. So that's negative 27 plus 20, which is what? Negative 7. So this is my minimum value. So your minimum value or your maximum value will be the y value of the vertex. Okay? So the minimum, if it asks you what a minimum value or a maximum value is, that's talking about the y value of the vertex. This is the lowest y value of my parabola, the lowest point of the parabola. Does that make sense? That's as far down as that parabola is going, is down to negative 7. So that's what you're doing. So if it asks you to do this, that's what you do. You tell me if it's a maximum or minimum by looking at your A term. Plug in, get your AOS, plug that in, get your y value of your vertex. Okay, let's do one more. Let me see if I can squeeze it in right here. Y equals negative 2x squared plus 4x plus 3.
ABC.
D, E, F, G. No, I'm just kidding. Is this going to be a maximum or a minimum?
Min.
Y'all sound like schminner.
Min.
Is this a U shape or upside down?
Heel.
Okay, so if it's upside, so that means the vertex up there, which is the highest point, which is a maximum. Yeah, it has to switch it in your brain. Okay, if A is positive, you have a minimum. If A is negative, you have a maximum. There you go. So how do we get the maximum? How do we know what the highest point is going to be? First, we get the what? AOS. X equals negative b over 2a. Negative what's b? Over 2 times what's a? Negative 2 times. So negative 4 divided by negative 4 equals what? Is that my answer? No, that's just the AOS. So how do I get my maximum value? Plug it in for all the x's. So it's like you're finding the vertex. So negative 2 times 1 squared plus 3. Watch your order of operations everywhere. 1 squared times negative 2 plus 4. And that's going to be positive 5. So this one's a maximum. And the maximum value is 5. So the highest point in that graph will be up at 5 on the y scale. You don't do that. This is all you're doing right here. You're not graphing. So if I was graphing, I'd graph that, then I'd pick an X. All right. So this is what you're going to do. The second part of your problems. You have 11 problems total to do for this lesson. So I'm going to hush and let you work on it. 6 graphs, and the rest are max and min stuff like this. Two, 21 through 26, 33 through 37. Quiz on Friday. And remember, if you owe me any quizzes or tests, I need those before Friday. So if you want to stay after, if you want to take one right now, whatever you need to do.